Hello everyone. In today's talk, I am going to present a paper from Chem European Journal titled Bipyridinium and Phenolphthaleum Dication for Metal-Free Hydrodefluorination for Distinctive Carbon-Based Reactivity. This paper reports of the use of organic dication as Lewis acid for catalysis of hydrodefluorination of aryl and alkyl CF bond under mild condition. The hydride ion affinity of bipyridinium and phenolphthaleum salt generates the sililium cation via hydride abstraction from the silane uh, and enables the sililium mediated catalysis. So the first report of the silyl cation was reported by uh, Lambert, while Milstein first reported the catalytic hydrodefluorination through silyl complex. Since then, HDF was demonstrated by transition metal and silane reductant. To establish comparable reactivity of the group elements, cationic aluminium germanium were also used as initiator. So Ozerov even used trityl carbocation as an initiator of HDF. There have been precedent of using carbon-based cation as Lewis acid, uh, such as electron-deficient alene, cationic boronium ruthenium complex, tarpyridyl hexacoordinate P5 dication, N-methyl acridinium salt, C60 and C70 fullerene, and triangulium cation. So in this work, it is shown that the simple bipyridine and the phenanthrolene dication can act as initiator for hydrodefluorination catalysis of mono, di, and trifluoromethyl derivatives. To assess the Lewis acidity of the bipyridinium and phenanthrolium cation, natural bond activation was done. The the extensive LUMO delocalization in the bipyridinium scaffold was reminiscent of the pyridinium-based NAD plus NADH coenzyme, which is known to accept hydride at the para position. The Lewis acidity is dependent on the ring substitution and extent of the ring delocalization. The extended conjugation in this 1E dication result in high HIA value of 61 kilocalorie per mole at orthocarbon and 38 kilocalorie per mole at paracarbon as compared to the phenanthrolene dication having 56 and 57 in the ortho and para position. The alkyl substitution of 1B, 2B, and 2C, and the methoxy substitution at the 1D dication result in diminished hydrogen in affinity. Uh, and with respect to the unsubstituted one, namely this 1A dication and the 2A dication. Note that at the site of the tarbutyl substitution, the of 1C, 2D, and 2E dication, there is an elevated HIA. This is presumably because of reduction of the steric congestion of the carbon atom after hydride donation. So this is the computed LUMO of the phenanthrolium and the bipyridyl dication. Using this calculation at hand, the following synthesis were done. The bromide salt were prepared by alkylating with dibromoethane at 130 degrees Celsius overnight. Then anion metathesis was done using trimethyl silyl triplet and trityl borate. The triplet and borate salt were recrystallized from acetonitrile and the pentane or orthodifluorobenzene solution, and following crystal structure were obtained. It was seen that the two-way dication borate salt was disordered. However, the dicationic nature was confirmed through the crystal structure. The initial trials using 2A borate to initiate HDF reaction for trifluorotoluene showed sluggish reaction in dichloromethane, which can be attributed to the poor solubility of phenanthrolium species in dichloromethane. This was monitored in 19F NMR, keeping hexafluorobenzene as a standard. Accordingly, the solvent screening was done using a range of halogenated and coordinating solvent, which led to the ortho-difluorobenzene showing superior performance. Despite the improved solubility in acetonitrile and pivalonitrile, no reaction was observed in this solvent. The observed order of reactivity of this dication followed that 2A was greater than 2B dication. Both of them were phenanthrolium cation, which is much greater than that of pyridinium dication, and subsequently which is greater than that of 1F dication. And this trend follows that HIA value. In addition of aryl CF3 derivatives, difluoro and monofluorobenzyl can undergo complete HDF. But cyclohexyl CF3 and adamantyl fluoride were converted to corresponding alkane. The bromide of 2 CF3 led to the effective HDF. In contrast, the ortho CF3 of benzophenone had diminished yield due to the complete hydrosilylation of the carbonyl moiety. The chloro derivative underwent complete dehydrochlorination. To understand the mechanism, the HDF mediated by phenanthrolium borate was monitored in 19F NMR in ortho-difluorobenzene at 40 degrees Celsius. The reaction was completed under 5 minutes, which is consistent with the result of Ozerov et al. The broadening of the phenanthrolium resonances suggested that reversible interaction between the silane and the dication. Using deuterated silane, triethyl silylium D, the HDF reaction was applied to the cis 246 CF3 cyclohexane. A single 2H NMR resonance was observed attributed to methyl group and consistent with the formation of the 246 CD3 cyclohexyl. The 90-minute NMR also showed that the complete consumption of the precursor. To probe the hydride interaction with the dication, the 2A and 2B were reacted with even more powerful hydride donor LiLH4, forming doubly reduced bright yellow neutral species, which were 1H NMR characterized and corresponding crystal structure were grown. Interestingly, 3A and 3B readily degrade under air, generating intense red product, but were uncharacterized. These 3A and 3B react with another equivalent of 2A borate and 2B borate respectively within seconds in room temperature to generate a purple colored solution. 1H COSY and NOSY NMR showed that the ortho and the para product form a 1:1 mixture through hydride transfer to the para position, which is consistent with the HIA value at the ortho and para position. In case of corresponding reaction of this 2A with the triethylsilane, the disymmetric product 4A was obtained. The reaction of 4A with the silyl borate again degenerated 2A plus, which is consistent with the notion that the organic dication reacts reversibly with silane, and the dication provides a slow generation of the silyl cation. Then the first silylium mediated HDF reaction with the CF bond activation and subsequently hydride abstraction to regenerate the active silylium cation each time. The computed calculation showed that the reaction of 1A diketen and the triethylsilane to be exergonic with del G of minus 39.9 kilocalorie per mole and hydrate abstraction from excess silane is thermodynamically favored, supporting this proposed reaction sequence. Thus, this paper established a simple uh, phenanthrolene and bipyridine derivative, carbon-based Lewis acid, which were evaluated for silarium catalyzed HDF reaction for a range of aryl and alkyl substituted mono, di, and trifluoromethyl groups. So, thank you for your attention.